Today's lesson is over the natural base exponential function. And the natural base is when your base is e. E is what we call the natural base. And E stands for Euler's number. It's an irrational number. And it's an irrational number because the number just goes on forever and ever and it has no pattern. E has an approximate value of 2.71828, and then it just goes on forever. So we're going to go ahead and graph e to the power of x. So we always start our table with the x values -2, -1, 0, 1, and 2. And to find the y values, you're going to do e to the first exponent, which is -2. Because this is a negative exponent, we're going to flip this number, make it 1 over e, and now this exponent is positive. Now remember, we just said that e is approximately 2.71828. So guys, go ahead and type this into your calculator. Let me know what you get. You're getting approximately what? 0.135? Okay, so I'll just put 0.1. Okay, the next one, same process. We're going to do e to the power of -1. Since your exponent is negative, you're going to flip it, and now your exponent is positive. So just type in 1 over 2.71828, and let me know what you get. So you said you got approximately 0.37? Okay, I'll round to 0.4. Okay. What is anything to the power of 0? 1. What's anything to the power of 1? Itself. There we go. So itself would just be 2.7. I'll round it to 2.7. And then finally we have e to the power of 2. So this is 2.71828 to the power of 2. Let me know what that is. Please round. 7.4. Thank you. So guys, this is the table that you need to have memorized. Write this on your index card. Okay, is this growth or decay?
Growth.
If you didn't look at the graph, how else would you know that it's growth?
Based on
The number increasing on y.
It is increasing on the y. That's very good. How else do we know? Based off of this equation, how would you know? When this number is greater than 1, that means it's going to be growth. If it's between 0 and 1, it's going to be decay. So if you look at your notes from yesterday, when we graphed 1/2 to the power of x, it was decreasing because 1/2 is between 0 and 1. So whenever it's decay, your base is between 0 and 1. And if it's bigger than 1, like e is, it's going to be growth. Your domain is always going to be all real numbers. For this function, do I have any vertical shift? Did it move up or down? Nope. So then what's my asymptote? 0. If you had plus a number, that would be the asymptote. Or minus the number, that would be your asymptote. But we don't have a number, so it's just 0. All right. So that means your range will be 0 to infinity. Okay, so I'm going to go ahead and graph it. 0, 1 is right here. 1, 2.7. 2, 3, 4, 5, 6, 7.4. And these are very small. So this is what your graph should look like. Your asymptote, always draw your asymptote. This is your asymptote at y equals 0. Your y-intercept is at 0, 1. It's never decreasing. It's a growth, so it's always increasing. It's increasing all the way from negative infinity to positive infinity. It is always increasing everywhere. So that's what you put for increasing interval. For your end behavior, as x goes to infinity, your graph is going up. So that will be infinity. As x goes towards negative infinity, what is your graph approaching?
0.
Yep, 0. It's approaching the asymptote at 0. Okay, so now that we know what the parent function looks like and the parent table, now you can transform it. So let's do an example. My base is e, so the parent function is e to the power of x. So I'm going to go ahead and write my table. We said that the table for e to the power of x is -2, -1, 0, 1, and 2. And then the y values were 0.1, 0.4, 1, 2.7, and 7.4. So you always start with the parent table. Now I'm going to apply the transformations. This is what it was originally. However, it's being compressed, vertically compressed. It's moving to the right 4 and down 2. So we're going to apply these transformations to this original table. Okay? So this went right 4. That means for the x column, we're going to add 4 to all of the x's. So that means my new table, the x values will be 2, 3, 4, 5, and 6. Those are my new x values. Everything else affects the y values. So this vertical compress, I'm going to multiply all of these y values, and I'll do it in a different color. Multiply these y values by 1/2. I'm going to multiply it by 0.5. Then you're going to subtract 2. So type this into your calculator, and these will be your new y values. Then you'll have your new points that you can put on your graph.
Why did you add 4 instead of subtracting?
Oh, I added 4 to the x values because the transformation is right 4. So all of your points are moving this way, towards the positive side. That's why you have to add.
So it'll be opposite.
Yes. Mm-hmm. Wonderful question. All right, guys, so once you type this into the calculator, 0.1 times 0.5 minus 2, you get -1.95. You do the same process, you get your y values, and you plot your points on the graph. Your asymptote is at -2 because it went down 2. This number will always tell you the asymptote. And notice the graph is increasing because your base is e, and e is bigger than 1. So if your base is bigger than 1, it will be a growth graph.